Hi, my name is Kirk Fleming. I'm an EMT and paramedic student, and I also have over 30 years working as an insurance company mathematician. I thought it would be helpful if I went through some calculations, actually wrote out some of the problems for some paramedic med math calculations. And I'm going to recommend a website called Paramedic Pearls and Pitfalls. This is a website by Chris Johnson, who's a Florida paramedic, and he is also a paramedic instructor. And on this website, he has some questions, 20 questions that he gives his students, and I'm going to go and work through those problems. I've been doing that over 3 videos. The first video dealt with how much medication to draw up in a syringe. The second video dealt with calculations that involve the patient's weight. So these were weight-based medical administrations. Then finally, the last one, this one, is going to have drip set calculations. Chris talks about the master formula, which is shown here on the left side of the screen. It's desired dose times the patient weight times drip set divided by the concentration of the medication divided by the time. So you can think of that as DD times W times DS divided by C times T, which is equal to Dunkin' Donuts was dropping sugar over their coffee and tea. The advantage to this formula is you only need to know this one formula. All the problems, you just use as much of the information as you have for this formula, and then you work it out and you get your right answer. So let's start. Your patient that you've been working with has been resuscitated after a couple of rounds of drug therapy, and now you must start a lidocaine drip at 3 milligrams per minute using microdrip tubing. How many milliliters how many drops per minute are necessary if the pump fails? So let's write down what we have for this problem. The desired dose we're given is, let's see, get a pen, okay. Desired dose is 3 milligrams. And the time is, we want to do that over 1 minute. The drip set that we're using is a microdrip set, so that's 60 drops per minute, per milliliter, I'm sorry. And the concentration, lidocaine is supplied in 2 grams per 500 mLs, at least in this example. This is what we're using. And I'm going to convert that into the common dosage or common unit of measure that we're doing the desired dose. So 2 grams is equal to 2,000 milligrams per 500, which is equal to 4 milligrams per ml. All right, so now that we have that, let's write out the information in the formula. The desired dose is 3 milligrams times 60 drops per milliliter divided by the 4 milligrams per milliliter, and that's times 1 minute. There are some things that cross off. We get the milliliters cross off, the milligrams cross off. What we end up with is 180 drips over 4 minutes, which is equal to 37 and a half if I do the arithmetic, so 38, we round up, 38 drops per minute. And that's the answer. Let's see. Erase that one, and we'll move on to the next question. All right, let me see. You are going to be initiating a nitroglycerin drip in the field for a patient with a confirmed STEMI. You have your micro drip tubing prepared, and you are to start the drip at 15 micrograms per minute. Your patient says he weighs about 180 pounds. All right. The drug dose, the drug medication isn't weight-based, so we don't need the weight. That was just extra information in here. The desired dose is equal to 15 micrograms. The time that we're administering this is 1 minute. We're using a microdrip set, so the drop set is equal to 60 drops per minute per milliliter. Keep saying that. The concentration, nitroglycerin in this example has 25 milligrams in 250 mLs. So converting that into the same units as the desired dose, that's 25,000 micrograms in 250 mLs, which is equal to 100 micrograms per ml. Putting that into the formula, desired dose, we have 15 micrograms times the 60 drop set per milliliter, all over the 100 micrograms per milliliter times 1 minute. Whoops. Let's see. All right. Some things cross off. Micrograms. I can cross off a 10 here. I have 6 times 15 is 90 drops over 10 minutes, which is equal to 9 drops per minute. M-I-N. 9 is the answer in that one. All right. Next question. You are responsible for starting a Diltiazem drip, Diltiazem drip, I believe that's pronounced, using microdrip tubing for her 200-pound male patient who has had a heart rate control via a bolus of Diltiazem several minutes ago. The protocol states that you are to mix 20 milligrams of Diltiazem in a 150 ml bag of D5W and deliver it at a rate of 5 milligrams per hour. How many drips per minute would be necessary if your pumps were to fail? All right, let's write out the information that we have. Desired dose is equal to 5 milligrams. And the time, that's 5 milligrams per hour. The time here in this case is 60 minutes. The solution set, the drop set, is equal to 60 drops per ml. And the concentration in this case is equal to, we were told to mix 20 milligrams in 150 mLs. All right. I'm just going to do the division over here so we can get that as a reduce it down to rate per milliliter or concentration per milliliter. I'll do the calculation here. 150 divided into 20. Okay, 150 goes 0 into 20. It goes once into 200. 0, 5. Okay. It goes 3 times into 500. And you can see this is going to be a continuing decimal, 0.15. So the concentration is 0.133 milligrams per ml. Let's put all this in the formula. We have 5 milligrams times the 60 drop set per ml divided by the 0.133 milliliters milligrams per ml times 60 minutes. 60 and the 60 cross off, the milliliters cross off, the milligrams cross off. What we end up with is 5 drops per 0.133 minutes. Okay, so that's not very helpful. We want to divide the 0.133 into the 5. When you have a decimal point over here, let's see, we move it once, twice, and 3 times. So you're going to move this once, twice, 3 times. That's where the new decimal point goes. 133 into 500 goes 3 times. And that's 399. 0. Okay. 101. It goes 133 goes 7 times into the 1010. That's let's see. That's 931. That's 0, 0, 9. Let's see. 3 from the 0 is 7 and 1. All right, and it goes, let's say, about 5 times. This next time, 5 times. So we're talking about 37.5 drops per minute. That's 38 drops per minute. And that's the answer in this case. Next question. All right, let me see. Okay, you're going to start a nitroglycerin drip for your patient. So you place 30 milligrams of nitroglycerin into a 100 milliliter bag and deliver it via microdrip tubing at a rate of 40 micrograms per minute. How many drops will that be? All right, so the desired dose in this case is equal to 40 micrograms. The time we're talking is 1 minute. The drop set is equal to 60. We're using microdrip tubing here in this case. And the concentration is equal to 30 milligrams per 100 mLs. That's equal to 3,000 or 30,000 micrograms per 100 mLs. which, let's see, take off 2, that works out to 300 micrograms per ml. If we put all this in the formula, we have the desired dose is 40 micrograms times the 60 drop set divided by the, let's see, we have 300 micrograms per ml times 1 minute. Alright, so we can cross off some things. This is drops per ml. Okay, so we have drops per ml, get crossed off the micrograms, get crossed off. I can cross off a 0 here, a 0 here. I'm ending up with 24 drops over 3 minutes, which is equal to 8 drops per minute. That's the final answer. All right, one more problem and then that'll be it. You have a patient who is suffering from a severe hypertensive emergency and you are ordered by medical control to deliver 20 milligrams of Labetalol over 2 minutes via IV push. You are then to administer 2 milligrams per minute afterwards to achieve a blood pressure that is reduced by 30% over where it started. You routinely mix your Labetalol infusions by adding 100 milligrams to a 150 milliliter bag using a 10-drop tubing. How many drops per minute does that equate to? All right, so there was two separate issues here. You gave an initial infusion of 20 milligrams over 2 minutes via IV push, but then we get into the drip set calculation. And we're saying the desired dose is equal to 2 milligrams, and the time over which we want to do that is 1 minute. And the drip set we're using in this case is 10 drops. This is a macro set per milliliter. And the concentration, we're told, is we add 100 milligrams into 150 milliliters. Oops, 150 milliliters. All right, which works out to 0.66 milligrams per ml. This is 2/3. 100 is 2/3 of the 150 in this example. To me, if you had your choice, it would probably make sense to mix 100 milligrams and 100 mLs so that you don't end up with these weird numbers, but that's what the problem is. So to put all this into the problem, we're mixing 2 milligrams times the 10 drops per milliliter drop set, and that's divided by the 0.66 milligram per ml concentration times 1 minute. All right. So this is 20 drops. Right, these cross off. This cross off. Divided by 0.66 minutes, which, if you do the division, works out to 30 drops per minute. All right. Yeah, I would think, being a student, I'm not there yet, but I would think it would make sense when you mix your medications into the bags that you would mix like units, just to do yourself a favor as far as the calculations go. I don't know what people practically do, but that's what I'm going to try to do. The last item, I lied, I have one more question. You are underway on a long transport and have been ordered to add 1 amp of phenytonin to a 150 milliliter bag of saline, which is to be run over 1 hour. How many drops per minute are you required to run? All right. Phenytonin. Let's see. This sounds a little different than the other ones, but this is exactly the same. And if you just follow the calculations through blindly, you'll automatically you'll get the right answer. Let's see. The desired dose is 1 amp, and the time. We're going to do this over 1 hour. This is 60 minutes. And the drop set is equal to, I'm going to make this a macro drop set, drops per milliliter. And finally, the concentration is equal to 1 amp per 150 ml. So let's write that out in the formula. We have 1 amp times the 10 drop set per milliliter divided by the concentration. That's 1 amp per 150 ml times 60 minutes. All right, so the milliliters cross off, the 1 amp crosses off. Let's see, we can take out a 10 here. So when I do the division, when you have this double division, that actually works out to 150 drips over 6 minutes. And that works out to 25 drips per minute. So that's it. Those are all the calculations I have. I hope this was helpful to you, and you guys have fun out there and good luck.